Okay, good morning all of you. Last week we have started to discuss about vectors. Okay, as we promised, today we are going to do first vector as our first session. Okay. Last time we have defined what is a vector and what are the differences between vectors and scalar quantities. Those are the things, those are the basic things we have discussed in last week. Okay. Today we are going to continue from that session. Okay. Up to now we have defined what is a vector. Then we have discussed about differences between vector quantities and scalar quantities. Okay. Now we are going to discuss about representation of vector. What is the representation of vector? Because in our previous discussion, I have clearly mentioned you that vector quantities cannot be mathematically add or subtract, or we cannot do mathematical operation like as scale quantities. So we have to do some mathematical operation to vector quantities. In order to do that thing, the first thing we should do is representing the vector. So now we are going to discuss about representation of vector. Okay, write a subtopic: representation of vector. Representation of vector. Okay, this is the first topic we are going to discuss today: representation of vector. Okay, as you already know, vector has two properties. What are those? Magnitude and a direction. So if we want to represent a vector, we should represent the magnitude of that vector as well as the direction of that vector. Okay, so now we are going to represent a vector using two ways. Okay, there are two methods to represent a vector. What are those? The first thing is geometrical representation. The second thing is algebraically representation. Geometrically and algebraically representation. Those are the two methods of representation of vector. Geometrical representation is representation of a vector as a figure. That means using a figure we can represent a vector. So geometrical representation is representation of vector using a figure. Something like, maybe you already know that one. We can represent a vector using a figure. So that is called as geometrical representation. Okay. Algebraic representation is we can use some algebraic notation such as A, B, P vector, A vector, something like those kind of symbols we can use to represent a vector algebraically. Algebraical means using a letters. Using a letters we can represent a vector. Okay. Geometrically is we can use a figure. To represent a vector. Those are the two methods of representation of vector. Okay. Write as topic: representation of vector. Under the topic, you can write this one. There are two methods. There are two methods. There are two methods. There are two methods to represent a vector. To represent a vector. To represent a vector. There are two methods to represent a vector in mathematical operations. In mathematical operations. Okay, you can write this one. Representing a vector can be done through two ways. First one is geometrical way, other one is algebraically. We can represent that one. Geometrically, algebraically. Geometrical means using a figure. Using a figure. Algebraically means using a words, English words. Using words. Okay. Once you write this chart, we can write a subtopic, geometrical representation. Geometrical representation. Geometrical representation. Okay. Geometrical representation. In geometrical representation, Puta, we have to use a figure. We have to use a figure to represent a vector. In this case, we have to represent, or we have to mention both magnitude and the direction of the vector using a figure. Okay. So in this case, we use a line segment. A line segment which is drawn into the direction of vector. Okay. A line segment. A line segment. This line segment is drawn into the direction of vector, and we can use an arrowhead. We can use an arrowhead to represent the direction of vector. Okay. Now one thing is sort of, no? What is that? Direction of the vector. We can use a line segment which is drawn into the direction of vector, and we can use an arrowhead to represent the direction of the vector. From this, we can sort out one thing. What is that? Direction of the vector. Now direction is okay. Then, how to represent the magnitude? How to represent the magnitude? In this case, we can use the length of the line segment. The length of the line segment to represent the magnitude of the vector. Now it is sort out now. We can use the direction of the line segment, and we can draw a line segment into the direction of the vector and use an arrowhead to represent the direction. And we can use the length of the vector to represent the magnitude of the length of this line segment to represent the magnitude of the vector. Okay. Suppose we have to represent 30 Newton force. We have to represent 30 Newton force. This is an example. Okay. We have to represent a 30 Newton force. In such case, we can assume 10 Newton. 10 Newton can be represented using 1 centimeter. 10 Newton is equal to 1 centimeter. This is an assumption. We can assume that one. Okay. So we can assume such kind of scale. Okay. We can assume such kind of scale, and from that, according to this assumption, we can draw 3 centimeter line segment into the direction of vector. We can draw 3 centimeter line segment into the direction of vector to represent 30 Newton force. 30 Newton force. This is very easy. So, how to represent a vector using a geometrical way? How to represent that one? In this case, we have to draw a line segment into the direction of vector, and we have to put an arrowhead into the direction of the vector. Then the length of line segment, should be represented the magnitude of the vector. Okay. To represent the magnitude of the vector, we have to assume some kind of scale. This is, you are free to assume this scale. Using this scale, we can represent the magnitude of the vector. Okay. Okay. Do you get my point? Everyone, I need your response. Okay. Good. Okay. After drawing this chart, you can write this subtopic, geometrical representation. Okay, geometrical representation. Geometrical representation. Right under that topic. Right under that topic. A line segment. A line segment with a magnitude and a direction. With a magnitude and a direction to a scale parallel to a vector. To a scale parallel to a vector. To a scale parallel to a vector is known as a geometrical vector. Is known as a geometrical vector. Therefore, we can draw a line segment. We can draw a line segment we can draw a line segment into the direction of vector, into the direction of vector, into the direction of the vector, and use an arrowhead, use an arrowhead, use an arrowhead to represent the direction of the vector, to represent the direction of the vector. The magnitude of the vector, the magnitude of the vector can be represented, can be represented can be represented by the length of the line segment, by the length of the line segment. Okay, in this case, we can write this as an example. If we want to represent a 30 Newton force, we can use a line segment which is drawn into the direction of the vector, and we can use an arrowhead to mention the direction. Then we can assume a scale. We can assume a scale to represent the magnitude of the vector. So I can draw 3 centimeter line segment. I can draw a 3 centimeter line segment to represent this 30 Newton force. Okay. Okay. Write this one as example. Write this one as example. Okay. Once you draw this figure. Write the next topic, algebraic representation. Yes, yes. You are free to choose a scale, okay? Okay. Once you draw this figure, write this topic, algebraic representation. Algebraic representation. Okay. Right under that note, topic, right under that topic, vectors or vector quantities. Vectors or vector quantities. Vectors or vector quantities can be represented. Can be represented. Can be represented. Can be represented algebraically by symbols by symbols such as okay. Once you write this one, write a comma and write under this symbols such as A, B, C, D, P, Q, O. Okay, right? Simple A, simple B, simple C, simple P. Or you can use capital A, capital B, those are some format of representation of vectors. Those are some format. We can use A, B, and we can put an arrow. We can put an arrow top of that letters. This means this vector starts from the point A and ends at point B, and the direction of the vector is A to B. A to B. Direction of the vector is A to B. A, B, C, D. The arrow should be top of the letters. Top of the letters. In mathematical operations, we can use this kind of very simple symbols to represent a vector. But if you want, when you using this kind of symbol, when you're using this kind of one letter symbol, you have to define that vector first. You have to define that vector first. That means, suppose this simple A vector is simple A vector is start from point A and end at point B. Suppose that one. So you have to mention that thing first. That means AB direction vector is equal simple A. AB direction vector is equal to simple A. You have to mention that thing first, okay? But when we do mathematical operation, normally we are use this kind of symbol because it is easy, because this is one letter symbols, no? But when you using this kind of symbol, first thing we have to define that vector first, okay? Otherwise we can use this one: A to B, C to D, P to Q, P to Q. From this one, from this notation, actually it is very clear. It is very clear the starting point and the end point of the vector. The starting point and the end point of the vector, and the direction of the vector. So from the starting point and the end point, we can measure the length of the vector. So I can get the magnitude of the vector, and it is mentioned the direction. It is mentioned the direction. So it is very clear, this one. This one is very clear. Okay. But we can use these kind of symbols too. Okay. Okay. Do you understand? Do you get my point, everyone? Yes, very good. Okay. You have to mention that thing. You have to mention this thing. Okay, right under this, other thing, normally in our papers, so in our tudes, you will receive some question. In question, vector can be represented as a bold capital bold letters, bold simple letters, black bold letters. Okay. Okay. Write that in two. Okay. In printing, they are denoted by black bold letters. Black bold letters. Black bold letters. Okay. You can write a note after that one. You can write a special note. Right under this special note. When we use in a simple letter, when you use in a simple letter, when we use in a simple letter to represent a vector, when we use in a simple letter to represent vector, we have to define that vector first. We have to define that vector first. We have to define that vector first. Okay. It is something like this. It is something like this. So look at the board. Okay. Suppose there's a vector from A to B. Suppose there's a vector from A to B. So vector starts from A and end at B. Okay. Suppose we are going to represent that vector from simple A letter. First, we have to define what is simple A. What is simple A? Simple A is AB vector. AB vector. So such kind of thing we have to do this kind of thing. Okay. You can write this as an example. Okay. Now we have discussed about representation of vector. Now we have discussed about representation of vector. Now we are going to discuss about the magnitude or modulus of the vector. What is a modulus? Okay. Modulus. That is something special name. Okay. Modulus. What is a modulus of a vector? Modulus mean the magnitude, Puta. Modulus mean the magnitude. This is something similar to magnitude. So modulus of a vector mean the magnitude of the vector. Magnitude. Normally, we represent the modulus. Modulus simple as like this. Like this. That means if you want to find the modulus of AB vector, we can write it as AB modulus of AB. Modulus of AB. So this is how we represent the modulus of the vector. Modulus means the magnitude of the vector. So this is equal to modulus or the magnitude of the vector. So modulus symbol is this one. Modulus. Modulus means the magnitude of the vector. Magnitude of the vector. Okay. Again, write a subtopic. Magnitude or modulus of a vector. Magnitude or the modulus of the vector. Magnitude or modulus of a vector. Magnitude or modulus of a vector. right under that topic. Magnitude or modulus of a vector, magnitude or modulus of a vector can be represented by the symbol can be represented by the symbol. You can write this one. Can be represented by the symbol. This one. Okay. As example, I can write this one. If I write this symbol, this means the magnitude of AB vector. Modulus of magnitude of AB vector. You can write this one. Okay. Shall we go for an example? Suppose this is a vector, and suppose this is equal to 10 Newton. This vector is equal to 10 Newton. So the magnitude of AB vector or modulus of AB vector is equal to 10 Newton. 10 Newton is the magnitude of that vector. Okay, magnitude of that vector. Okay. You will write this example too. Okay, we have discussed up to modulus of a vector, or modulus or magnitude of a vector can be represented by this kind of symbols. Actually, this is a universal symbol. This can be used to any quantity, not only the vector quantity. We can use that symbol also for a scalar quantity. Suppose we have to take the modulus or magnitude of -2. So if you have this kind of symbol, around the -2, that means you have to take the magnitude of -2. Magnitude of -2 means it is just a 2. It is just 2. Okay. So this symbol, modulus symbols, means the magnitude of any quantity, not only vector quantity. It is a universal symbol. We can use we can use this symbol for any quantity. If we use this symbol for any quantity, that means we are going to take the magnitude of that quantity. So we can use this symbol for vector 2. If we use this symbol for vector, that means we are going to take the magnitude of the of that vector. Okay. As an example, this one. Suppose you have 10 Newton force from A to B. So if you are going to take the modulus of AB vector, that is equal to 10 Newton. Okay. Okay. Then we are going to discuss about some special vectors. The first thing is we are going to discuss about null vector. Null vector. Null vector means zero vector. Zero vector means, Puta, if any vector, if the magnitude of any vector is equal to zero magnitude. Okay. If the magnitude of any vector is equal to zero, that vector is called as a null vector. A null vector. Normally we denote that null vector. This symbol. Zero symbol. Then the magnitude of this zeroth vector, null vector, is equal to zero. Magnitude is zero. Okay. Okay. Write a topic. Some special vectors. That is our topic. Some special vectors. Okay. The first subtopic under that topic is null vector. Null vector. Within the brackets, you can write the symbol of null vector. Symbol of null vector is equal zero vector. Zero vector. Null vector. Right under that topic. If the magnitude of any vector, is zero, it is called as a null vector. Null vector. Okay, you can write this one. The symbol of null vector is equal to this one. The magnitude of the null vector is equal to zero. Okay. The second special vector is unit vector. Unit vector. Unit vector. The symbol of unit vector is U. U. You can understand what is the feature of the unit vector. What are the features of unit vectors? No, unit vector. Okay. Unit vector means if the magnitude of a vector is equal to 1, it is called as a unit vector. Unit vector. Okay. The symbol is U. Right under that topic. If the magnitude of a vector, if the magnitude of a vector is equal to 1, is equal to 1, is equal to 1, it is called as a unit vector. It is called as a unit vector. It is called as a unit vector. You can write this one. Symbol is U. Magnitude of the vector is equal to 1. 1. Okay. Third one is negative vector. Negative vector. Normally we call that it is called as reverse vector. Reverse vector. Reverse vector or negative vector. Reverse vector or negative vector. That is the third topic. Okay. This is the most important thing. Okay. Suppose we are given a vector. We are given a vector AB. A to B. Okay. Now, suppose we need to find the negative vector or reverse vector of AB. How to do that? What is the definition of reverse vector? Reverse vector is the vector which has the same magnitude, as AB, but the direction is opposite to AB. Direction is opposite to AB, but the magnitude are same. Right? The magnitude are same. Suppose CD. This is called as the reverse or negative vector of vector AB. Okay. Okay. Suppose we are given any particular vector. The negative vector of that particular vector is the vector whose the magnitude is equal to the magnitude of the previous vector. but the direction is opposite to the given vector. Okay, very simple thing, but this is very important thing when we are going to calculate or when we are going to do some mathematical operation for vectors. So we need to distinguish those kind of negative vectors when we are going to do some mathematical operations. Okay. Okay. Negative vector or reverse vector. You can draw this one. You can draw this one. First, you have to draw this one. Right under this drawing, the negative vector or the reverse vector of a particular vector is the vector whose magnitude is equal to the given vector and the direction is opposite to that, is opposite to the given vector, That means Those are the features of negative vector. Okay, those are the features of negative vector. So if it is a negative vector, AB and BC, magnitude should be equal. Magnitude of AB vector and CD vector should be equal. Okay, so the length of AB should be equal to length of CD. That is a mandatory thing. Other thing is, both line segments should be parallel to each other. No? Same direction. No? Same direction. Direction means the direction is same, but the vector direction is opposite to each other. Okay. Therefore, these two line segments are parallel to each other. AB parallel to CD, but the directions are opposite to each other. Opposite to each other. So the only difference between the vector and the negative vector is the arrowhead. Arrowhead direction. Arrowhead direction is opposite to each other. Okay. Those are the features of the negative vector. You can write this one. Features of the negative vector. Features of the negative vector. AB and CD is equal. AB should be parallel to CD, but the direction means arrowhead directions is opposite to each other. Okay. Have you noted down this one? Shall I erase this one? Shall I erase? Thank you. Okay. Until now, we have discussed about definition of the vector. Then we have compared vector and scalar quantities. Then we have discussed how to represent a vector. Then we have discussed about the modulus of the vector, and finally we have discussed about some special vectors. Okay. Now we are going to discuss about some basic feature of some vectors. Okay, I think you have noted down this one, no? Okay, I will erase this one. Okay. Suppose we are given two vectors. Suppose we are given two or more than two vectors. Among those vectors, we have to select some equal vectors. Then we should decide. We have to decide how to select equal vectors. Okay. Because when we are doing vector calculations, we have to decide equal vectors. Okay. Therefore, equality of two vector is very important thing. Very important thing. Write a topic. Write a topic. Write a topic. Equality of two vectors. Equality of two vectors. Okay. You know vectors are the physical quantity that has a magnitude and a direction. So, if any two vectors are equal, all their features should be equal separately. All their features should be equal separately. Okay, that means both the magnitudes of two vectors should be equal and the directions should be equal. Other thing, magnitude should be equal, direction should be equal. Other thing is the homogeneity. Homogeneity means both should be same physical quantity. Same physical quantity. That means suppose we are given 10 Newton force. 10 Newton force. We are given 10 Newton force. And we are given 10 meter displacement to the same direction. We are given 10 meter displacement into the same direction. Okay. So if we consider the magnitude and directions, both are same, no? Both have same direction, both have same magnitude. But one vector is a force, other vector is a displacement. So we cannot equate in different physical quantities. Physical quantities. So if we want to equate two vectors, both vectors should be measured, should be represent the same physical quantity. That is a mandatory thing. Mandatory thing. Okay. So if any two vectors are equal, then their magnitude should be equal, the direction should be equal, both should be represent the same physical quantity. That means they should be homogeneous. Homogeneous means they should be represented the same physical quantity. Same physical quantity. Okay. Do you understand? Do you get my point? Yes. Others? Okay, good. Okay. Write the topic. Equality of two vectors. Equality of two vectors. Write under the topic. Write under the topic. Vectors are the physical quantities with magnitude and directions. If any two physical quantities, if any two vector quantities, are equal, The following features should be fulfilled. The following features should be fulfilled. The first feature is magnitude. Magnitude should be equal. Magnitude should be equal. Magnitude should be equal. The second thing, directions should be same. The third and most important thing is both vectors should be represent the same physical quantity. Should be the same physical quantity. Both vectors should be represent the same physical quantity. Example adakam. As example, we can write AB 10 Newton force and 10 meter displacement. CD. Okay, right under this. According to above diagram, the magnitude and the direction, the magnitude and the direction of this one, AB vector and CD vector. You have to write this. You have look at the board. AB vector. You have to write this way. AB vector and CD vector. AB vector and CD vector. are equal. Are equal. But the AB vector, the AB vector represents a force, and CD vector represents a displacement. CD vector represents a displacement. Therefore, those vectors cannot be same. Those vectors cannot be equal. Those vectors cannot be equal. Okay. Suppose we are given two homogeneous vectors. Homogeneous vectors means same physical quantities. Okay, both have same physical quantity. So suppose we are given two homogeneous vectors A, B, and C, D. A, B, and C, D. So if A vector A equal vector B, then what will happen? There should be following features. If A vector is equal to B vector, there should be following features. That means the magnitude of both vectors should be equal. Sorry, magnitude of both vectors should be equal. So magnitude of AB. Sorry, I can write this one. If A vector is equal to B vector, then modulus of A vector is equal to modulus of B. That means the length of AB line segment, should be equal to the length of CD line segment. So AB length should be equal to CD length. Very important thing. Okay. If there are two equal vectors, magnitude should be equal, then their line segment, length of their line segment should be equal. That's the first feature. The second thing, the directions are equal. Therefore, AB line segment should be parallel to CD line segment because their length should be equal. AB line segment should be parallel to CD line segment. Both are equal. The third feature is the direction of arrowhead. Direction of arrowhead should be equal. Direction of arrowhead arrowhead should be equal. Okay. Did you get my point? Okay, Bhute. You can draw this one. You can draw this one and write this one. Right. Suppose A and B are homogeneous vectors. Homogeneous vectors. Homogeneous homogeneous vectors. If A equal B, then the magnitude should be equal. So AB equal CD. AB should be parallel to CD. Then should be equal. Okay. Shall I erase this one? Thank you. Others? Okay. Okay. We have discussed about the definition. Then we may discuss about the comparison between scalar quantities and vector quantities. Then today onwards, we discuss how to represent a vector geometrically and algebraically. Then about the modulus of vector. Then some special vectors, null vector, reverse vector, and the unit vector. After that, we have discussed how to equate in two vectors. Okay. Do you have any questions up to now? Do you have any questions? If you have any questions, please let me know. I will explain that one.
No, sir.
Very good. Others? Okay. Okay. Shall you do some exercise, Then shall you do some exercise? Okay. In here, you are given some homogeneous vectors. Okay. You are going actually you are asked to find equal vectors and negative vectors among these given vectors. Okay. Perfect. Okay. I will give you 20 minutes. 20 minutes to complete this one. Now it is about 9:30. I will give you 20 minutes to complete this one. The first question and third questions ask to distinguish equal vectors and negative vectors. The second question, you have to find some vectors. In second question, you have to use your trigonometric knowledge. Okay. In second question, you have to use your all-level geometry knowledge as well as the trigonometric knowledge to solve that problem. Okay. Within 20 minutes, please complete this one. Okay, everyone, please listen me. First, you should do first one within 5 minutes. Okay, within 5 minutes, first do the first one. Do the first one first. Then we will discuss and go to the next one. Okay. So if you have any correction to be done, then you can correct that thing in second and third question. Okay. Let's do the first question and send me the answers. Do the first question, send me the answers. Then we can discuss and go to the second and third question. Good. Okay. Shall we discuss? Shall we discuss? Equal vectors. What are the equal vectors? Equal vectors. Listen very carefully, Puta. Listen very carefully. If any two vectors are equal, there are three features to be fulfilled. No, there are three features. What are those features? Length should be equal. Length should be equal. Then the directions mean the arrowhead should be equal. 13 is already equal because it is given. All the vectors are homogeneous vectors, so it is given. So the first and second thing, that means the length and the directions should be equal. Length is the length of the line segment. The direction is the arrowhead direction. The arrowhead direction. Okay. Then what are the equal vectors and what are the reverse vectors? What are the equal vectors here? Equal vectors. You can clearly see, Putabalan. You can clearly see this one and this one. A and C. A and C. As this is a parallelogram, AB length and CD length are equal, no? Because the opposite side, the length of opposite sides are equal. Therefore, the length of AB and length of CD are equal. Okay. The direction, look at this. The direction of arrowhead are equal. So I can say AB vector and CD vector, DC vector. That means vector A and vector C are equal vectors. Those are equal vectors. Now you can consider the other two sides, because other two sides are also equal, no? In a parallelogram, other two sides are also equal. But look at this. Look at this. Sides are equal, but the arrowhead direction, they are opposite in direction, no? They are not equal. They are opposite in direction. So, Puta, those are not equal vectors. Those should be negative vectors. Negative vectors are vectors. The magnitudes are same, but the directions are opposite, in opposite direction. So, D and B vector are in opposite direction. Okay. As this is a parallelogram, you know, this length and this length should be equal, and this length should be equal separately. Okay. Then, if you consider the vector AO, that means vector R and vector Q. Vector R and vector Q. If you consider the vector R and vector Q, what do you can say? both have same magnitude. No, because AO equal OC. Both have same magnitude. But the arrowhead directions are in opposite directions, opposite ways. Therefore, R and Q are two negative vectors. Okay. The same as in this one, no? Same as in this one. You know OD equal OB, OD equal OB, as this is a parallelogram. Therefore, magnitude of P and magnitude of S are same, but the arrowhead, look at the arrowhead. Arrowhead in opposite direction, but the arrowheads are in opposite direction. Therefore, they are not same. They are not same. They are some kind of negative vectors. Everyone, do you understand how did I do this question? Do you understand? Again,
Yes, sir.
Okay, thank you. Again, I will share that thing. When you are doing this question, please draw the question, Puta. Please draw the question. Don't write it straight way. I will explain how to write this one. I will explain how to write this one. Please look at the board. Please look at the board first. A, B, C, D, and O, no? A, C, B, C, O. Okay. Okay. The first thing you have to do, copy down the diagram to your notebook. Otherwise, don't do without the diagram. Okay. Okay. After copying the diagram, how to write this one? How to write this one? Suppose you are going to compare A and B, means A and C. If you are going to compare A and C, write in this way. A and C. A and C, no? Look at this one. AB equal DC. AB equal DC. So what is the reason? Reason is ABC is a parallelogram, no? Because ABCD is a parallelogram. Now length is okay. Then the direction, the arrowhead direction. Arrowhead direction of A to B is equal D to C. D to C. D to C. Other thing is AB parallel to DC. Ne? AB parallel to DC. AB parallel to DC, and arrowhead direction is equal to arrowhead direction of DC. All of these features are in A and C vectors. Therefore, A and C vectors should be equal. Therefore, A equal to C vector. A vector and C vectors are equal vectors. Okay. Then again you can compare with AD and BC, AD and BC, AD and BC, AD and CB. If I compare AD and BCB, you know, AD. AD is equal to CB. AD is equal to CB. And AD parallel to CB. But arrowhead direction arrowhead directions are unequal. Arrow directions are unequal. Then we can say B vector is the negative vector of, so this is D, no? Wait. This is D. This is D. B vector is negative vector of D. Negative vector of D. Okay. You can write this way, in this way. First you have to consider the length, then the arrowhead direction. Arrowhead direction and the whether these are parallel or not. Whether those are parallel or not. AD equals CB, then AD parallel to CB, but arrow directions are unequal. Then we can say B is equal to negative D. Negative D. That means those are negative vectors. Same kind of thing can be done comparing AO and CO. AO and CO. AO equal CO. AO equal CO. Then we know AO those are in same direction, no? That means those are in parallel. CO, but arrowhead direction. Arrowhead directions are unequal. Unequal. Arrowhead directions are unequal. That's mean R vector is a negative vector of Q. R vector is the negative vector of the Q vector. Okay. Same thing can be done for OB and OD. OB and OD. OB and OD. Okay. Okay. Everyone, I need your response. Do you understand? How did I get the answers? Do you understand? Everyone?
Yes, sir.
Very good. Very good. Thank you, Muta. Then you can do the third question before second question. Okay. Third question first. Okay. First thing you have to copy this down. Okay. Please copy the diagram. Then you can select what are the equal vectors and what are the negative vectors. Please do within 5 minutes and send the answers to me. Okay. Good. Shall we discuss? Look at the direction of arrowhead again and again. Look at the directions of arrowhead. Okay, there are two parallelograms. Okay. Uh, in this question, Pute, I think it is better to write this one. It is better to write AB length and AF length. AB length and AF length are equal. AB length and AF length are equal. AB and AF are equal. Then DC and ED are equal. Okay. I missed that thing. You can assume that thing. You can assume that thing. Then you can get more and more equal and negative values. Okay. Suppose AB, your answers are okay, but I have do some correction, not a correction, additional information to the question. What is that? The AB length and AF length are equal, and CD length and DE length are equal. Okay. If those are equal, are there any other negative numbers, negative values, or negative vectors, or equal vectors more than you sent me? Suppose they are equal. Okay, shall we check in here? I will draw the diagram first. B A Q S D C E G F R and P. Okay, now look at the board. According to the final data, those are equal. That means its length are equal. Okay, now you are going to you have to check the equal values, equal vectors. Equal vectors means length should be equal, arrowhead should be equal, Puta. The first thing, length should be equal. Look at the three things. Length should be equal. Then both line segments should be parallel to each other. Then the arrowhead should be equal. Those are the three things to be fulfilled. What are those? What are those? When you are deciding whether it is a equal vector or a negative vector, you have to decide three things. What are those three things? The length of the length of this line segment, then the parallel, whether those are parallel or not. The third thing is the arrowhead. Those are the only things you have to decide. Okay, those are the only things you have to determine when you are going to evaluate whether those are equal vectors or not, equal vectors or reverse vectors. Those are three things. Now, as these two A, B, C, D and A, D, E, F are parallelogram, we can consider the opposite sides of these parallelogram, because I know if it is a parallelogram, opposite sides are parallel and equal. In a parallelogram, opposite sides are parallel to each other and length of the opposite side are equal. Therefore, first and second things will be fulfilled in the opposite side of a parallelogram. And then consider the opposite side parallelogram opposite sides. The first thing you have to do to check the opposite sides of each parallelogram. Okay. Look at this. If I consider these two, first ABCD. First I consider ABCD parallelogram. First thing, AB and DC. AB and DC. AB and DC are two opposite sides in the parallelogram. Therefore, lengths are equal, and these two sides are parallel to each other. This is a parallelogram. Therefore, first two things are fulfilled. Okay. When you are again and again, please understand this. Okay. Listen to me. When you are evaluating, when you are determining whether the whether the two vectors are equal or negative vectors, you have to determine these three things. You have to determine whether the length are equal, whether those are parallel or arrowhead. Okay. Okay. Both negative vectors and equal vectors, length and both have same length. Both line segments are parallel to each other. The only difference is arrowhead. If it is if they are equal vectors, the arrowhead directions are equal. If they are negative vectors, arrowhead directions are opposite to each other. That is the only thing. Okay. That's why I said earlier, when you are comparing the sides of parallelogram, take opposite sides of the parallelogram, because opposite sides of the parallelogram are parallel to each other and the length of the opposite sides are equal to each other. Therefore, the first two things are fulfilled. Then you have to decide this thing only. So if I compare AB vector and DC vector, AB and DC vector, if I compare AB and DC vector, you know, as this is a parallelogram, AB is equal and parallel. You can write it is at one time. Equal and parallel to DC. Equal and parallel to DC. You can write it at one time. The second thing, look at the arrowhead. Arrowheads are equal, no? Arrowhead directions are equal. Arrowhead directions are equal. Arrowhead directions are equal. A is equal to C vector. Therefore, vector A is equal to vector C. Vector A is equal to vector C. Do you understand? Okay. I have taken these two. Then I can go to next opposite sides. This one, B and C. Okay. You can clearly see others are equal, but the arrowhead direction. Look at the arrowhead direction of B and C. Look at the arrowhead direction B and D. They are in opposite direction. No, they are in opposite direction. So B and D. If I take B and D, AD direction of AD equal and parallel to BC, CB. But arrowhead directions are in opposite. Arrowhead directions are not equal. Arrowhead are not equal. Therefore, D and B are negative vectors. D and B are negative vectors. So I can write vector D is equal to negative vector B. Negative vector B. Okay. Then again, you can consider this one too, no? Because this is a parallelogram. Also, this is a parallelogram. When you compare these two, you can clearly see both are parallel to each other, length are equal as this is a parallelogram, and arrowhead direction. Look at the arrowhead direction. Arrowhead directions are same. Then D and F are equal vectors. 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 Then again F and B. And F and B are negative vectors. So I can write this one, okay? I will categorize them. Equal vectors and negative vectors. What are the equal vectors? A and C, no? A and C. We have find that one. Found that one. Then F and D. Negative vectors, D and B are negative vectors. D and B are negative vectors. And F and D. F and D, look at this. Arrowhead are in different ways. Arrowhead are different in F and D. Okay. If any vectors are same or equal or negative, both are parallel to each other. Parallel to each other. So compare the parallel vectors. Do not compare other vectors. Okay. Do not compare other vectors. Vectors should be parallel to each other. If any vectors are equal or negative or reverse, both of them are parallel to each other. So when you are comparing two vectors, they should be parallel to each other. So don't compare other vectors. Don't compare other vectors. Vectors should be parallel. Then take another parallel vectors. Then take another parallel vectors. Look at this. Now I can take this parallelogram. This parallelogram E and G. E and G. You know E and G. ED and AF both have same magnitude as this is a parallelogram and they are parallel to each other. Then look at the arrowhead. Look at the arrowhead. Arrowhead directions are different to each other. Different to each other. So they should be negative. They should be negative. So E is a negative vector of G. E is a negative vector of G. The negative vector of G. Okay. Okay. Then, according to our last assumption, AB and EF are equal. Now I can compare these two. These two. You can see AB and AF. AB and AF. AB and AF. AB and AF both are same in magnitude, same in direction, but the arrowhead directions are opposite to each other. Arrowhead directions are opposite to each other. Therefore, so A and G. Therefore, the vector A is the negative vector of vector G. Negative vector of vector G. Okay. According to that, you can see this one and this one. You can see AB and ED. AB and ED. Look at this. AB and ED. AB and ED. The length of AB and length of ED are same. Length of AB and length of ED are same. And they both are parallel to each other. Both are parallel to each other. Therefore, A should be equal to E. Should be equal to E. And you know, A is equal to C. Therefore, this one is equal to, I can write this one is equal to E. Okay. Okay. Now I have considered all the outer sides of the parallelograms. Now I can go to the inner sides. Okay. Do you understand what I did here? Everyone. Do you understand? Yes. Thank you. Thank you. Only thing you have to consider the parallel vectors. Okay. Parallel vectors, puta. Don't compare not parallel vectors. Don't compare not parallel vectors because if it is a equal vector or negative vector, the two vectors should be parallel to each other. Two vectors should be parallel to each other. So compare the parallel vectors only. That's why I go to the outer sides first. Then I can go to the diagonals. You can see these two parallelograms are equal to each other. Because I gave ABC equal to AF. Therefore, these two parallelograms are equal to each other. Therefore, this diagonal, AE diagonal and BD diagonal should be equal to each other and should be parallel to each other. Then you can clearly see this thing. R and P, R vector and P vector. R vector and P vector are equal because their arrowheads are in the same direction. Therefore, R vector should be equal to D vector. Then the vector S means this vector, this diagonal vector. This diagonal vector and this diagonal vector should be equal in magnitude and parallel to both each other, but the arrowhead, look at the arrowheads. Arrowheads are in opposite direction. Therefore, they should be negative vectors. So S is a negative vector of Q. S is a negative vector of Q. Okay. Okay. Do you understand? The first thing you should do, don't compare not parallel vectors. Okay. If you want to find an equal vector or if you want to find a negative vector, both should be parallel to each other. Okay. Both negative vectors and equal vectors are parallel to each other. Therefore, if you want to find a negative vector or equal vector, you have to compare two parallel lines. Okay. Do not compare this. Do not compare the two diagonals in same parallelogram. Okay. Two diagonals in the same parallelogram are not parallel to each other. Okay. Don't compare that one, Puta. Right? Therefore, you have to compare two parallel lines. When you comparing two parallel lines, you have to decide whether those are equal in length or not. If they are equal, then you can go to the next factor. What is that? Arrowhead factor. Okay. You have to decide the arrowhead direction, whether it is in the same direction or not. Very easy thing. Okay. Okay. Do you understand? You can write this one. Once you write this one, you can take a 10-minute breaks and come to the class at 10:30. We will start again at 10:30. Once you write this one, you can take a break. Okay, 10-minute breaks. Okay. Shall we start after break? Meanwhile, there is another negative vector. Thank you for remembering that one. G and C are another negative vector because those are equal in magnitude, parallel to each other, and arrowhead directions are in opposite directions. Okay. Okay. That is enough for today's for vectors. Okay. Now we are going to discuss about basic mathematical operations, basic mathematics. That's about trigonometry. So take your book. Now we are going to discuss about trigonometrics. Okay. Last time I asked to do some homework. Okay. Look at this one. Homework. ඔයාලා හොඳට කරලා තිබ්බා. අතරම පුතේ homework upload කරන්න ඊට පස්සේ ඒක upload කරන්න. මොකද ඒක ඕගොල්ලන්ටමයි වටින්නේ. මොකද ඕගොල්ලන්ගේ තියෙන mistakes මන් ලව්වා හදව ගන්න. මොකද නැත්තම් ආයි තව අවුරුද්දක් විතර ගිහිල්ලා මේ ඕක හදන්න බෑ. මේක හොඳට මතක තියාගන්න. මම ආයි මේ කියන්නේ ඕගොල්ලන්ගේ mistakes හදන්න පුළුවන් මුල් කාලෙම හදනවා නම් හදන්න පුළුවන්. අවුරුද්දක් විතර ගියාට පස්සේ ආයි නම් අල්ලන්න අමාරුයි. මම ඕගොල්ලන්ගේ ආශා ඉස්සලත් කිව්වා. මතක තියාගන්න අපි මේ යන මේ පාත් එක පටන් ගත්ත තැන ඉඳන් ඉවර වෙනකම්ම යන්න ඕන. පටන් ගත්ත තැන ඉඳන් ඉවර වෙනකම් යන්න ඕන නැත්තම් අපි නොයා ඉන්න. මේක හොඳට මතක තියාගන්න. ඒක නිසා හොඳට මේ අර ආර්ට් කොමර්ස් වගේ නෙවෙයි මම ඒවා මේ පල්ලෙට දාලා කතා කරනවා නෙවෙයි. නමුත් ඒවා පාඩම් කරනවා වගේ නෙවෙයි ඒවා ඒ පාත් එක යනවා වගේ නෙවෙයි සයන්ස් පාත් එකට ගියා කියලා කියන්නේ. ඒක මුල ඉඳලම අපි ඉන්න ඕනි මැද්දෙන් අපිට ඇවිල්ලා වැඩ කරන්න බෑ. ඒකයි තියෙන ඩිෆරන්ස් එක. හරිද? ඔයාලා තාම මේක තේරෙන්නේ නැහැ. තාම ඕගොල්ලෝ මෙතන ආව විතරයි. නමුත් අපි දැන් අවුරුදු ගාණක් උගන්වලා අපි දන්නවා. දැන්ට උනත් අවුරුදු සාමාන්‍යයෙන් එක්සෑම් එකට මාස 6ක් විතර තියලා ළමයි යන ක්ලාස් වාගේ. සර් මට මේක බැරි වුණා. මට මේ ටික බෑ. මට මේ ටික බෑ කියලා. අරගත්තට පස්සේ බලනකොට මෙලෝ මගුලක් කරලා නැහැ අවුරුදු ගාණක්. හරිද? එතකොට ඒ වගේ ළමයි ඕනි තරම් ඉන්නවා. දැන් අපි අවුරුදු ගාණක් තිස්සේ අත්දකින්න දෙයක්. අවුරුදු එකහමාරකට විතර පස්සේ තමයි එකහමාරකට දෙක කිට්ටු වෙනකොට තමයි ළමයිට තේරෙන්නේ දැන් මට කෙලවෙලා කියලා. හරිද? ඒ තත්ත්වෙටපත් වෙන්න එපා. ඒක මම කියන්නේ මික්ස් මිස්ටේක්ස් තියෙනවා නම් මුලින් ඉඳලම ඒක හදාගෙන යන්න. ඒක තමයි most important day. හරිද? ඒක නිසා homework ටික අප්ලෝඩ් කරන්න කිව්වම අප්ලෝඩ් කරන්න. ඒක අරකට අප්ලෝඩ් කරන්න මොකක් හරි මේ දැන් තියෙනවා මට පර්සනල් හරි කමන්නේ වන්. හරි. ඒක නිසා හොඳට මතක තියාගන්න හැබැයි නොකර ඉන්න එපා. මන් ලව්වයි ටික මේ බලලා මාක් කරගන්න. මොකද ඕගොල්ලන්ගේ මිස්ටේක් මම තේරුම් ගන්න ඕනේ. පළවෙනි දේ ඒක. හරි. හොඳයි. Okay. Shall we go to the questions? Question number 4. Question number 4. In question number 4, we are given the value of tan theta, and we asked to find the other trigonometric ratios. In such cases, it is easy to draw a triangle. It is easy to draw a triangle. Suppose ABC is a triangle and this is theta. ABC and a triangle, this is theta. According to given data, tan theta is equal to 3/4. 3/4. According to our definition, you know what is the tan theta? Tan theta is opposite side over adjacent side. Opposite side over adjacent side. So, according to this fraction, opposite side is equal to 3, while the adjacent side is equal to 4. Opposite side is equal to 3, while the adjacent side is equal to 4. Then you can use Pythagoras theorem to find the hypotenuse. Find the hypotenuse. So what is the hypotenuse? It should be 5. It should be 5, no? It should be 5. So now you have found all the sides of the triangle. If you know all the sides of the triangle, you can write any trigonometric ratio. No? Once you found the AC length, you can write sin theta. It is opposite side over hypotenuse, 3/5. 3/5. Then, if you know the sin theta, you can write cosec theta too. Cosec theta means the reciprocal of the sin theta. That means hypotenuse over opposite side. So 5/3. Then go to the cos theta. Cos theta. So cos theta is equal to the adjacent side over the hypotenuse. In here, adjacent side is 4, hypotenuse is 5. Then you can write the value of sec theta. Sec theta is the reciprocal of cos theta. Reciprocal of cos theta means 5/4, 5/4. Hypotenuse over the adjacent side. Then tan theta, you know the tan theta. Then cot theta. Cot theta means the reciprocal of tan theta. Reciprocal of tan theta means 4/3. 4/3. Do you understand? It is easy to draw the triangle. Once you draw the triangle, you can find the unknown side. Okay. Then again, something similar to the fourth question. Sin theta. In this case, we are given sin theta value. Sin theta value. So draw a triangle. Draw a triangle. Mark a angle theta. ABC. According to given data, sin theta is equal to 12/13. 12/13. 12/13 means sin theta means opposite side over hypotenuse. Opposite side over hypotenuse. So opposite side over hypotenuse is 12/13. 12/13. So if you know these two sides, you can find the other side using the Pythagoras theorem. If you use the Pythagoras theorem, square of 13 minus square of 12. What is the answer? 5, no? 5. It is 5. 169/144. 169 minus 144 means 25. 25 square root of 25 is 5. Okay. If you have large numbers, and suppose you cannot find the exact value very quickly, then you can use difference of squares to solve this method. Difference of squares. You can clearly see this is 2 square. Difference of 2 squares. No? So difference of squares means 13 plus 12 into 13 minus 12. 13 minus 12, 1. No? So you can take 13 plus 12 only. 13 plus 12. 13 plus 12 into 13 minus 12. Difference of squares. Difference of squares. 13 plus 12 means 1. So 1 into anything is this thing. Therefore, you can take 13 plus 12 as the answer of this one. 13 plus 12 means 25. So you can take the square root of 25. The square root of 25. You can calculate this thing using your mind. Okay. Don't write anything in the book. Okay. Okay. Once you calculate the other side, now you have all the 3 sides. Now you can write any trigonometric ratio. You have written the sine theta. So cosec theta is the opposite side. Cosec theta is 13 over 12. Then cos theta. Cos theta is adjacent side over hypotenuse. Adjacent side over hypotenuse means 5 over 13. Then tan theta is equal to opposite side over adjacent side. Opposite side over adjacent side means 12 over 5. 12 over 5. Opposite side over adjacent side. 12 over 5. 12 over 5. Sec theta is the opposite side of this one. Reciprocal of this one. Tan theta is the reciprocal. Sorry, cot theta is the reciprocal of this one. Okay. Everyone, I need your response. Do you understand how did I solve this matter? Good. Very good. Okay. You can solve. You can do the same thing up to question number 8. So I am not going to solve those questions because you have not submitted your homework. So again, I'm going to give you a chance. You can do this thing and upload that to me. Okay, up to question number 8. Then I will teach about question number 9. Question number 9 only. Question number 9. Cot theta. We are given cot theta. Again, we can draw a diagram, Puta. We can draw a triangle and mark cot theta. A, B, C. Cot theta. We are given the cot theta is B squared minus A squared square root. Cot theta. Cot theta is adjacent side over cot theta is adjacent side over opposite side. Adjacent side over opposite side. So I can write this one as a fraction. I can write this one as a fraction. Actually, we are given this one only. This is only a number. But any number can be written as a fraction, because any number we can write as a fraction, because the denominator of a number can be taken as 1. Denominator of an integer number can be taken as 1. So any number can be written as a fraction. If it is a whole number, if it is an integer, that means the denominator part is equal to 1. Denominator part is equal to 1. So any whole number can be written as a fraction. Fraction is also a fraction. It is a fraction, no? Any whole number can be written as a fraction because the denominator is equal to 1. So I can represent this thing in our triangle. So according to this one, the adjacent side is equal to this one, b squared minus a squared, and the opposite side is equal to 1. Opposite side is equal to 1. Now you want to find the hypotenuse. How to find the hypotenuse? You can use the Pythagoras theorem. You can use Pythagoras theorem. So AC squared is equal to AB squared plus BC squared. AB squared plus BC squared. So AB means this one. Is square root B squared minus A squared is square plus BC means 1. Square of this square root, square of any square root is this number. No? It is equal to this number. So it is equal to B squared minus A squared plus 1. B squared minus A squared plus 1. Okay. Because the square root of any number is equal to that number. The square root of 2. The square of square root 2 is equal to 2. No? The square root of square root 2. The square of square root 2 is equal to 2. Equal to 2. Square of square root 3. Square of square root 3 is equal to 3. So square of any square root should be equal to that number. Okay. Therefore, square of square root b squared minus a squared is equal to b squared minus a squared. This is AC square. But I want to find AC. AC mean square root of this entire thing. Square root of this entire thing. B squared minus A squared plus 1. Okay. That is enough. We cannot simplify further this one. We cannot simplify further. Okay. You can stop here. Okay. So AC is this one. AC is B squared minus A squared plus 1. Now you know all the length of all the sides. Now you can find any trigonometric ratio. Sin theta is opposite side over hypotenuse. Opposite side is 1. Hypotenuse is B squared minus A squared plus 1. Cos theta. You can write cos theta. Cos theta is adjacent side over hypotenuse. Adjacent side is square root b squared minus a squared. Hypotenuse is square root b squared minus a squared plus 1. Okay. Tan theta is the opposite side of the cot theta, the reciprocal of the cot theta. So tan theta is equal to 1 over b squared minus a squared. B squared minus a squared. Okay. Everyone, do you understand this one? Do you get my point? How I did my calculation?
Yes, sir.
Thank you. Others? Very good. Very good.
So can't we take it as a square?
Sorry? I didn't hear you, Puta.
So instead of keeping it as a square root, can't we take it as a square?
You mean this one?
No, sir, the hypotenuse AC.
Yeah, hypotenuse. Yeah.
Can't we take AC equals b minus a squared instead of the square root?
How can we may take that one? Actually, we have to find the AC value, no, Puta. We have to find the AC value. Okay. We have to find the value of AC. Then you should wait a minute. Then you should take the square root of this one. Okay. You means you have stopped here. You cannot stop here, Puta.
Okay, sir.
Just apply the Pythagoras theorem. Don't do anything. Just apply the Pythagoras theorem. If you apply the Pythagoras theorem, you have to take the square of this length, this side, and you square of this side. Okay. When you apply the Pythagoras theorem, you have to take the square of this side and the square of this side, and both should be added. Both should be added. Both should be added. This is equal to the square of AC. Square of AC. Then you have to find the AC. If you want to find AC, you have to take the square root of this one. The square root of this one. The square root of this one not equal to. Now I understand. You means you have taken like this. Huh?
Yes, sir.
No. We cannot do that. I will explain that one. I will explain that part. Okay. If you finish writing, please let me know. I will explain that one. I will explain. Shall I erase this one? Have you finished writing? No.
Yes.
Okay, thank you. Others? Okay. I will explain that about that question. This one. Okay. First thing. What is the answer for a plus b square? What is the answer for a plus b square? Tell me. How to expand this one? Go. Tell me. How to expand this one? Huh? A squared. Then okay. Yes. A squared plus b squared plus 2ab නේ. 2ab නැත්නම් ඔක මිඩල් එක දාන්නත් පුළුවන් ab. A squared plus b squared plus 2ab. If you are given this one, a minus b entire square, how to expand this one? How to expand this one? A squared plus b squared, the middle part, you have to multiply these two and get the twice of that value. Okay, that means minus 2ab. Minus 2ab. Okay. The first thing you have to understand. The first thing you have to understand is, if you are given any plus value or any minus value, the square is a plus value. That means if you are given plus a, if you are given plus a to square, your answer is a square. If you are given minus a to take square, your answer is plus a. So plus a square. So there is no any negative square value. There is no any negative square value. Okay, you cannot take a negative square value. Okay. Other thing is the opposite side. Opposite side means can you take the square? Can you find the square root of a negative square? You cannot do that, no. If you take the square of a positive value or negative value, you will have a positive square value. Okay, positive square value. So if you can take the square root of this one, positive square root, but you cannot take a square root of this one, no. You cannot take a square root of this one. I don't know that one. Because this is a negative value. This is a negative value. The first thing is you cannot take a square root of a negative value. That is a first thing. Okay. Other thing is this one. If a plus b, if you take a plus b square, you will have this one. So if you take the square root of this one, you will have this. You will have this. If you take the square root of this one, you will have this one. Okay. As an example, you can take the square of this one. B squared minus A squared plus 1. Can you take the square? Sorry, not this one. Not this one, this one. B minus A plus 1. How to take the square of this one? How to take the square of this one? As you remember, I have taught that thing in our previous lessons. I have taught how to take the square root of three terms expression. How to take a square of, not a square root. How to take a square of three terms algebraic expression. How to take that one? Can anyone remember? Okay, I will explain that one. If you don't know, write that one. How to take the square root of three terms algebraic expression. How to take square of three terms algebraic expression. If you don't know, you can write it as a note. Okay. How to take a square of three terms algebraic expression. First thing, you have to take the square of each and every terms. That means A plus A squared plus B squared plus C squared. Then do the same thing what we did in two terms algebraic expression. What we did previously, we have multiply two terms and take the twice of that. You have to do the same here. But the thing is, there are three terms. So you have to take multiplication of this one, multiplication of this one, and multiplication of this one. You have to take three multiplications instead of one multiplication. Okay. In previously, we have done the same thing, but there were only two terms. Therefore, we have to do one multiplications only. But here, there are three terms. Therefore, I have to multiply these two separately, and these two separately. I have to take three multiplications. So first thing is AB, take AB multiplication and get the twice of that, 2AB. Then get the BC multiplication and take the twice of that, 2BC. And take the AC multiplication and get the twice of that, 2BC, 2AC. We have 1, 2, 3, 4, 5, 6 terms, no? Likewise, you can multiply this one. You can take the square of this one. How to take the square of this one? B squared plus A squared plus 1. First, you have to take each and every square of each and every terms. Then take the multiplication of two pairs separately and take the twice of that. First, these two, B and minus A. B and minus A means minus AB. Minus AB, twice of minus AB means 2 minus AB. Minus 2AB. Then this one and this one. Minus A and plus 1. Minus A and plus 1. Take the multiplication of that one. That means minus 1. Take the twice of that one. That means 2A. Then finally, this one. A, B and 1. Take the multiplication of these two numbers. B into 1 means B. Take the twice of that one. That means plus 2 times B. Plus 2 times B. Therefore, the square of this thing is equal to this one. Not to this one. Okay. Do you understand? Therefore, the square of this thing is equal to b squared plus a squared plus 1 minus 2ab minus 2a plus 2b. Okay, not to this one. Okay, not to this one. Square of this one and this one is unequal. Okay, do you understand? Do you understand? Okay, you cannot take square of each and every term separately. That cannot be done. Okay, that cannot be done. If you are given this kind of more than one terms, this kind of expression, in this expression, there are 3 terms, more than 1 terms. So in any expression more than 1 term, you cannot take square root separately. You cannot take square root separately. Okay, do you understand? Everyone, I need your response.
Yes, sir.
Thank you. If you anyone who need to write this expansion, please write that one in your basic mathematics book. Okay, shall I erase? Again, I need to say, if you have any questions regarding this sum, please let me know. If you have any question, I will explain again. Okay. 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 Then shall we move to the theory part? Shall I erase this one? Okay. Okay. Today we are going to study about Cartesian plane. Cartesian plane. Cartesian plane with quadrants. quadrants. Cartesian plane with quadrants. That means you know about Cartesian plane. According to your oral syllabus, you should learn about Cartesian plane. Cartesian coordinate. In Cartesian plane, there are two axes, two perpendicular axes. The horizontal axis is called as x-axis, and the vertical coordinate is called as y-axis. So those are the components of Cartesian plane. Cartesian plane. Okay. There are two axes, x and y. I think you know that one. So this is called as the Cartesian plane. Cartesian plane. Okay. Suppose if we draw a circle, the center of circle is the origin. If the center of circle is the origin for 0, 0 coordinate, if we draw a circle, and if the center of the circle is this 0, 0 point, you can clearly see this circle is divided into four similar parts. No, this circle is divided into four similar parts. Okay, therefore one section of this Cartesian coordinates is called as a quadrant, because it is a 1/4 of this circle, Therefore, one section, this section is called as a quadrant. This section, another quadrant. This section, another quadrant. This section, another quadrant. So it is called as quadrant. As a standard, according to the standard notation, this section is called as the first quadrant. And this section is called as the second quadrant. And this one is called as the third quadrant. And this one is called as the fourth quadrant. Okay, you can clearly see in the first quadrant. The y-axis, the y value of the first quadrant is positive. No, you know this thing. If this is the origin, to this side, y values are positive. To this side, x values are positive. And to this side, x values are negative, and to this side, y values are negative. Okay, y values are negative. Okay. Therefore, x and y. So if I compare the value sign of x and y, first, second, third, fourth. So in the first one, second one, third one, fourth one. Okay, look at this one. In the first one, you can clearly see the y values are positive and x values are positive. No, x and y values are positive in first one. Okay, so x values and y values are positive in the first one. Look at the second one. The second ones that consist of negative x-axis and positive y-axis. Negative x-axis and positive y-axis. So in the second one, y-axis is positive, but the x-axis, it is negative. So x value is negative in the second one, y value is positive. Look at the third one. Third one is formed by the negative x-axis and the negative y-axis. Look at this one. Negative x-axis and negative y-axis. So in the third one, x value is negative and y value is also negative. Okay. Look at the fourth one. In fourth one is formed by these boundaries. These boundaries, no? What are those boundaries? Negative x-axis, so negative y-axis and positive x-axis. Negative y, positive x. Those are the boundaries of fourth quadrant. Therefore, in fourth quadrant, x value is positive, but y value is negative. Okay. Look at this again. The first quadrant is formed by these boundaries. Positive y-axis, positive x-axis. The second quadrant is formed by these boundaries. Negative y-axis and positive, so negative x-axis and positive y-axis. Third quadrant is formed by negative x-axis and negative y-axis. Fourth one is formed by negative y and positive x-axis. Okay, those are the boundaries of quadrants. Therefore, in each quadrant, the sign of x and y are like as. Okay. Do you get my point? What do you understand? What is a quadrant and what are the x and y values? What are the sign of x and y values in each quadrant? Can you understand that one? Thank you. Others? Thank you. Okay. Okay. Then write a topic. Main topic: Cartesian plane with quadrants. Okay. You can draw the first diagram. Don't do the table. Don't write the table. Don't copy paste the table. Draw this image. Okay. basic mathematics book, basic mathematics. Okay, we have to write this one in basic mathematics. Okay, trigonometry lessons are trigonometry lesson should be written in basic mathematics book. Okay, basic mathematics. Now we have 3 books. Okay, first one is basic mathematics, second one is first unit and dimension book, third one is mechanics book. Okay, mechanics book. Among these 3 books, we have to use basic mathematics book. Sorry, my mic was mute. You can write under this diagram, Puta. You can write. Suppose a circle is constructed is constructed is constructed on the Cartesian plane, on the Cartesian plane, on the Cartesian plane with the center at the origin, with the center at the origin. it is clear. It is clear. It is clear that the circle is divided into 4 equal parts. Is divided into 4 equal parts. By the Cartesian coordinate. By the Cartesian coordinate. Therefore, one section, therefore one section, therefore one section of the plane, of the Cartesian plane, is called as a quadrant, is called as a quadrant, is called as a quadrant. Therefore, there are 4 quadrants in a Cartesian plane. Therefore, there are 4 quadrants in a Cartesian plane. Okay, write in another paragraph. each quadrant is bounded by two sides of x and y axis. Two sides of x and y axis. Okay, this is how we define the quadrants. After that, we don't want to draw a circle. Okay, quadrant means this is the first quadrant, this is the second quadrant, third and fourth. Okay, you can simply identify this quadrant without a circle. Okay, without a circle. I have drawn this circle because it is a definition. It is the how we define a quadrant. Okay, after that we don't want to draw a circle. Okay, okay, write a subtopic. Signs of x and y values, in each quadrant. Signs of x and y values in each quadrant. Signs of x and y values in each quadrant. Now you can draw this table. Shall I erase this one? Shall I erase this one? Thank you. Okay. Then we can go to the next section. That is, now we are going to produce a, or going to construct the projection of a line segment on x and y axis. Okay. Projection of a line segment. Suppose there is the Cartesian coordinate y and x. Y and x. And suppose we are given a line segment something like this, A and B. A, B. Projection. Projection means, suppose if we incident some light beam, from this side, the shadow of this line segment on x-axis is called as the projection of this line segment on the x-axis. Okay, again, if we incident a light beam, from this side on this AB line segment, the shadow of this line segment on this x-axis is called as the projection of the AB line segment on the x-axis. We have to project a parallel line segment. Okay, parallel light. Okay. If we incident a parallel light beam, from this side, the shadow of AB on y-axis is called as the projection of AB on y-axis. Projection of AB on y-axis. So how to construct the projection? Projection is the shadow of the AB due to a parallel light beam. So the only thing we have to do is, parallel light beam is this kind of thing, this kind of thing is called as parallel light beam. So if I incident a parallel light beam on AB, the shadow, I can obtain the shadow using two perpendicular lines from A and B to the x-axis. So this is the shadow, this is the projection, or this is the shadow of AB on x-axis. Okay. So if I incident a parallel light beam from this side, on AB, so we can obtain the shadow of AB. I can extend this one. If I extend this one, I will have the two perpendicular lines from A and B to y-axis. So this is the projection of A and B on y-axis. Okay. So simply you can remember how to take the projection of a line segment on x-axis, you can draw two perpendicular lines. You can draw two perpendicular lines from each points of the line segments to the x-axis. If you want to draw the projection of AB on y-axis, you have to draw two perpendicular lines from each ends of the line segment to the y-axis. Then you can obtain the projection of AB on y-axis. Do you understand? I need your response.
Yes.
Thank you. Then you can write the topic and draw this Cartesian coordinate. So AXB projection of AB on x-axis. Okay, Bhuti. Write this one under your drawing. We can draw two perpendicular lines. Two perpendicular lines from each ends of the line segment, from each ends of the line segment to the particular axis, the particular axis to obtain the projection of the line segment, on that axis, we can draw two perpendicular lines from each ends of the line segment to the particular axis to obtain the projection of the line segment on that axis. Okay. Do you understand up to now? Everyone. Do you understand up to now? Because we are going to discuss about circular functions. Circular functions after that. It is about trigonometric functions, because in trigonometric functions, according to our previous definition, we use a triangle. We use a triangle to define trigonometric ratios, but you know, there may be infinite number of angles. No, there may be infinite number of angles, because angle is amount of rotation. No, angle is defined as the amount of rotation. So angle can be any number. So there may be infinite number of angles. Therefore, we have to define trigonometric ratios for all of those angles. Therefore, in our next session, we are going to discuss about circular function in the next week. Okay. Okay. today I did not do anything about our unit and dimension tube because I receive only one answer sheet. Okay, only one answer sheet. That is very disappointing. Okay, I receive only one answer sheet from English medium class. Single medium class I received that many answers, but in English medium class I receive only one answer sheet. I don't know why. මතක තියාගන්න පුතේ මම ආයෙසරක් කියන්නේ ආයෙ පාරක් කියන්නේ මෙතන මගේ එක්ස්පීරියන්ස් එක තියෙන නිසා තමයි මම ඔයගොල්ලන්ට කියන්නේ මෙන්න මේ විදිහට කරන්න කියලා. හරිද? ඒ විදිහට කරන්න කියලා කියන්නේ ඕගොල්ලන්ගේ මේ දැන් තියෙන මිස්ටේක්ස් ඕගොල්ලෝ දැම්මම හදා ගන්න ඕනේ. ඒක හොඳට මතක තියාගන්න දැම්මම හදා ගන්න ඕනි. ආයි ඒක පස්සේ හදන්න බෑ. පස්සේ හදන්න බෑ. මෙතන ඉන්න ගොඩ දෙනෙක් මම හොඳටම දැක්කලා තියෙනවා ගොඩක් දක්ෂ ළමයි. ගොඩක් දක්ෂ ළමයි ඉන්නේ. ඒක නිසා ඕගොල්ලන්ට ගන්න පුළුවන් තැන තියෙනවනේ. ඒක පල්ලෙහාට දාගන්න එපා. ඒක පල්ලෙහාට දාගන්න එපා. හරියට කියන දේ කරන්න. කියන දේ කරන්න කියන්නේ group එකට දාන්න බෑ නම් මට personally වань. මට personally වань මට කිසි ප්‍රශ්නයක් නැහැ. මොකද මම අඳුර ගන්න ඕනේ ඕගොල්ලෝ ඉන්න තැන. මම එදත් කිව්වා ඔය ළමයි කාට හරි personally මට මොකක්ද තේරෙන්නේ නැත්නම් මට personally කතා කරලා කියන්නේ සර් මට මේක තේරෙන්නේ නැහැ කියලා මම අනිවාර්යෙන් ඔයගොල්ලන් කාට උනත් මේ මම වෙනම personally individual class එකක් දාලා මම කරනවා. individual class එකක් දාලා කරනවා කිය මම ඒ ඔයාලට තේරෙන්නේ නැති මම වෙනම කියා දෙන්නම්. ඒක ඕනි කෙනෙක්ට මේ කතා කරලා කියන්න පුළුවන් මම ඒවා without any charge මේ I will do that okay. මම ඒ තරම් chance එකක් දීලා තියෙද්දි පුතේ ඒ chance එකේ ප්‍රයෝජන ගන්න. හරි? ඒකයි මේ වගේ class එක තියෙන මේ කියන්නේ මේ වගේ class එකකින් ගන්න තියෙන දේ ඒකයි. හරි? එහෙම නැතුව අපි නිකන් බොරුව ටියුට් ගොඩ කුඩ ගහගෙන තේරුමක් නැහැ ටියුට් ගොඩ ගහලා කරන්නේ නැත්තම්. හරි? ටියුට් ගොඩ ගහලා කරන්නේ නැත්තම් මොකටද කියන්නේ? ඒ නිසා හොඳට මතක තියාගන්න කරපු ටියුට් එක එවන්න කරපු ටියුට් එක එවලා ඕගොල්ලන්ගේ මිස්ටේක්ස් ඕගොල්ලෝ බලාගන්න. හැමෝටම මම කියන්නේ කීප දෙනෙක් විතරක් නෙවෙයි ක්ලාස් එකේ ඉන්නේ. හැමෝම මේ දේ කරන්න. හරිද? හැමෝම මේ දේ කරොත් ඉතින් ක්ලාස් එකේ කී දෙනෙක් ඉන්නවද මට බලන්න පුළුවන් ඒ කට්ටියගේ මේ මොන වගේ රෑන්ක්ස් තියෙන්නේ කියලා. හරිද? දැන් මට ඊට පස්සේ කරන්න ඕනි මේ ලෙසන් එක මොනතරම් ඩීප් යන්න ඕනිද මොනතරම් ලේසියෙන් මම කරන්න ඕනද කියලා මට තේරුම් ගන්න ඕනේ ඕගොල්ලෝ ඉන්න මට්ටමත් එක්ක. හරි? ඒ නිසා ඕගොල්ලෝ ආන්සර්ස් එවනකොට හැමෝම ආන්සර්ස් එවන්නේ කියන්නේ ඒකයි. ඒ කියන්නේ ඔයා ඒකට දක්ෂ වුණත් එකයි ඔයා ඒක ටැලන්ට් එකක් තියෙනකත් දක්ෂ වුණත් නැතත් කමක් නැහැ. මට හරියට හදන්න පුළුවන් වුණත් බැරුණත් එවන්න. දක්ෂ ළමයි කට්ටියක් විතරක් එවුවොත් ඉතින් ඔක්කොම ආන්සර්ස් හරි මං හිතන් ඉන්න ඔක්කොටම හොඳ පුළුවන් කියලා. ඒ වුණාට මන් දන්නේ නැහැ සමහරු ඉන්න පුළුවන් තේරෙන්නේ නැති. හරි? ඒකයි මං කියන්නේ මේක යූස් කරන්න හරියට. යූස් කරලා තමුන්ගේ ඒ ගන්න තියෙන දේ 100% ගන්න. මම හැමදාම කියන ඔන්ලයින් ක්ලාස් එකක් ගත්තොත් එimhe ඔන්ලයින් ක්ලාසස් එකල ඇඩ්වාන්ටේජ් ගොඩක් තියෙනවා. හැබැයි තියෙන එකම ඩිස්ඇඩ්වාන්ටේජ් එක මට ඕගොල්ලන්ගේ පේන්නේ නැති එක. ඒ දේ නැති කරන්න මම මේ හදන්නේ. මට ඕගොල්ලන්ගේ පේන්නේ නැති එක නැති කරන්න මම හදන්නේ. මොකද ඕගොල්ලෝ මට ඕගොල්ලන්ගේ මේ ෆොටෝ මේ ඕගොල්ලෝගේ නෝට් එක ඕගොල්ලෝ හදපු මේ ටියුට් එක මට එවනවා නම් ෆොටෝ ගහලා ඒ කියන්නේ මට ඕගොල්ලන් පේනවා. එහෙනම් ඒ ඩිස්ඇඩ්වාන්ටේජ් එක මට නැති කරන්න පුළුවන්. හරි? ඒක මම මේ කියන්නේ කරුණාකරලා ඒක මේ කියන්නේ ඒක අහන්න කියන්නේ. මොකද මේ විදිහට මම මේ කියන්නේ මොක කවුරු හරි ඕගොල්ලන්ගේ කාට හරි මොකක් කරන්න තේරෙන්නේ නැත්නම් you are free to ask okay. ඔයාලට මට මේ අනිවාර්යෙන් මේ contact කරන්න පුළුවන් කිසිදු ප්‍රශ්නයක් නැහැ. contact කරලා මම අනිවාර්යෙන් ඕගොල්ලන්ට වෙනම free lesson එකක් දාලා මම ඒක කරනවා. ඒක කවුරුත් දැනගන්නේ නැහැ. යදාල් පුද්ගලයා සහ මම විතරයි. හරිද? අපිත් එහෙම තමයි ඉගෙන ගත්තේ පුතේ. මොකද මාත් මේ මට හොඳට මතකයි අපි A level කරන කාලේ අපි මොකක් කරන්න ඔතෙන් තැනක් තියෙනවා නම් ක්ලාස් එකේ ඉවරලා ගිහලා සර්ගෙන් අහනවා. විශේෂයෙන් ෆිසික්ස් වලදී මම අනිවාර්යෙන් මේ අහන්න තැන් ගොඩක් තියෙනවා. මොකද ෆිසික්ස් කියන්නේ අනිවාර්යෙන් තේරුම් ගන්න ඕන දෙයක් නේ. ඒ නිසා ඉස්සරහට යද්දී ඕනි තරම් දේවල් තියෙනවා අහන්න. අර පාඩම යද්දී ගොඩක් වෙලාවට අපි අහන්නේ නැහැ. පාඩම යද්දී ගොඩක් වෙලාවට අහන්නේ නැහැ කියන්නේ බැරි වෙලාවත් ඉතින් මේ ඩිස්ටර්බ් වෙයි කියලා ඊට පස්සේ අනිවාර්යෙන් ඔක්කොම ටික අහලා තමයි ඊළඟ වීක් එකට එන්න කලින් අපි යන්නේ. හරි? ඒක නිසා හොඳට මතක තියාගන්න මොකක් හරි නොතේරෙන තැන් තියෙනවා නම් ඕගොල්ලන්ට මගෙන් අහන්න පුළුවන්. හැබැයි ඒක එක්ස්කියුස් එකක් නෙවෙයි ටියුට් නොකර ඉන්න. ටියුට් නොකර ඉන්න එක්කෙනෙක්ටවත් එක්ස්කියුස් එකක් නෙමෙයි. යුනිට් එක නොතේරුණා කියන එක එක්ස්කියුස් එකක් නෙමෙයි. තේරෙනවද? යුනිට් එක නොතේරුණා නම් තේරෙන්න මම 10 පාරක් හරි කරනවා කිව්වොත්. පර්සනලි මම කරනවා මම ඕගොල්ලන්ට කියලා තියෙනවා පර්සනලි මගෙන් අහන්න කියලා. ඒ නිසා ටියුට් එක නොකර ඉන්න ඒක එක්ස්කියුස් එකක් නෙමෙයි. ටියුට් එක කරා නම් ඒක අප්ලෝඩ් කරන්න මට ඒක බලන්න. හරි. ඒ නිසා හොඳට මතක තියාගන්න ඊළඟ වීක් එක වෙනකොට මම හිතනවා මේ කියන දේ හරි අහලා ඊතුරු කට්ටිය මට අප්ලෝඩ් කරයි කියලා ගෲප් එකට දාන්න කැමති නම් මට පර්සනලි එවන්න. ඒක කමන්නේ. හරි. ඒක නිසා මේ ගෲප් එකට දාන එකේ ඇඩ්වාන්ටේජ් එක ගන්න කියලා මම ඔයගොල්ලන්ට කිව්වා. ඒකත් ගන්න නැත්තම් මට පර්සනලි එවන්න ඒත් කමන්නේ. නමුත් එවන්න නැතුව ඉන්න එපා. ඒක මම කියන්නේ. හරි. මොකද ඒකෙන් තේරුමක් නැහැ. අවසානයේදී තේරුමක් නැති වෙන හැමදාම කියනවා මගේ මතක තියාගන්න. අර අනිත් සබ්ජෙක්ට්ස් වගේ නෙවෙයි පුතේ මේ මැත්ස් ෆිසික්ස් කියලා මැත්ස් සයන්ස් කියන්නේ. මැත්ස් සයන්ස් කියලා කියන්නේ ඇත්තටම මාරම ක්‍රිටිකල් සබ්ජෙක්ට් එකක්. මොකක් හරි මිස් වුණොත් ආයි පස්සේ අල්ලන්න බෑ. හැම ළමෙක්ටම අවුරුද්දකම වගේ මම මේ කියනවා. කියන්නේ ගොඩක් වෙලාවට ළමයි තේරුම් ගන්න ඕක අවුරුද්දක් දෙකක් ගියාට පස්සේ. හරි සර් මෙහෙම කිව්වනේ කියලා තේරුම් ගන්න අවුරුද්දක් දෙකක් ගියාට පස්සේ. ඊට පස්සේ ඉතින් ආයි කොච්චර ගත් වැඩක් නැහැ. හරිද? හැබැයි මතක තියාගන්න මේ මම මේ කරන දේවල් ඔයාලා රිසල්ට් එනකොට ඔයාලට තේරෙයි අනිවාර්යෙන් මොකද්ද මම මේ කරේ කියලා. හරි? ඒකයි මම මේ කියන්නේ පුතේ. ඒක මම හොඳට මතක තියාගන්න. ඒ දේ අහන්න මොකද මම පෞද්ගලිකව මම සෙකන්ඩ් ෂයි මම කැම්පස් ගියේ ෆස්ට් ෂයි ඉතින් මට මේ මම ඔයගොල්ලන්ට කියලා තු ෆස්ට් ෂයි මම ඒ කියන්නේ මුල් කාලේ වැඩ කළා ඊට පස්සේ නැතුණා ඒ නිසා මම දන්නා වැඩ කරාම මොකද වෙන්නේ වැඩ නොකරාම මොකද වෙන්නේ කියලා මම දන්නවා කොහෙද ළමෙක්ට වරදින්නේ කියලා මම දන්නවා හරිද මොකද මටත් වැරදිලා තිබ්බ නිසා හරිද හැබැයි මම ඒක හදාගත්තා ඊට පස්සේ අවුරුදු ගානක් තිස්සේ දැන් මම උගන්වලා ඒ ඉගෙන ගත්ත ගෝලීන්ට මොකද්ද කරපු දේවල් කොහොමද ඒගොල්ලෝ හරි ගියේ කොහොමද වැරදුනේ ඒ ඔක්කොම මම දන්න නිසා කියලා හරිද මොකද ඕගොල්ලෝ තාම අලුත් මේකට තාම පටන් ගත්ත විතරයි පුතේ ඒලෝ පටන් ගත්ත විතර කියන්නේ හරියට ඕගොල්ලෝ මේ ලයිෆ් එක ස්ටාර්ට් කරා වගේ ඕගොල්ලන් හරිද ඕගොල්ලන්ගේ මේ කැරියර් එක ඔයගොල්ලෝ පටන් ගත්තා වගේ මොකද ඉස්සරහට ඕගොල්ලෝ මොකද්ද කරන ජොබ් එක කියලා ඩිසයිඩ් කරන්නේ මේ එක්සෑම් එකේ හරි ඒ නිසා හොඳට මතක තියාගන්න තමුන්ගේ කැරියර් එක තමුන් වෙස් කරගන්න ඕනේ නැහැ ඒ නිසා හරියට ඒ කියන දේ කරන්න හරි මම ඒ නිසා ලබන වීක් එකේ මේ කතාව අයිපාර කියන්න මට තියන්න එපා ඒ නිසා ඔයගොල්ලෝ එවන්න ඔයගොල්ලන්ගේ හෝම්වර්ක් ටික මට එවන්න හරි හොඳයි ඒකත් කියලා අපි අද ක්ලාස් එක නතර කරමු රෙකෝඩින් බලන කටයුතු මම මේ කියන්නේ රෙකෝඩින් බලන ළමයි කීප දෙනෙක් ඉන්නවා පර්සනලි මම දන්නවා ඒගොල්ලන්ටත් එක්ක මම මේ කියන්නේ පුතේ ඔයගොල්ලොත් රෙකෝඩින් බලලා අනිවාර්යෙන් මට ඒ හෝම්වර්ක් ටික එවන්න හරිද නැත්නම් රෙකෝඩින් බලන කට්ටිය මම කොහොමත්ම දන්නේ නැහැ කියන්නේ ක්ලාස් ලයිව් ක්ලාස් වෙන කට්ටිය නම් මම දන්නවා මේ උත්තර දෙන විදිහ හරි මොකක් හරි කරලා රෙකෝඩින් බලන කට්ටිය මම කොහොමත්ම දන්නේ නැහැ මේ කරාද නැද්ද කියලාත් හරියට හරිද ඒ නිසා ෆීස් දෙන එක නෙවෙයි මම වැදගත් වෙන්නේ හරිද වැඩේ කරන එක අනිවාර්යෙන් වැඩේ කරන එකයි වැදගත් වෙන්නේ ඒ නිසා හොඳට මතක තියාගන්න හැමෝම හෝම්වර්ක් එවන්න හරි හොඳයි එහෙනම් අපි අද ක්ලාස් එක නවත්තමු පුතේ so now we are going to stop the class okay have a nice day
Thank you, sir. God bless you.
Thank you, sir. God bless you.
God bless you